Flight times from LAX to New York are normally distributed. The average flight time is 320 minutes and the standard deviation is 20 minutes. So what we're faced with here is a nice little question, and we're told that our random variable, the thing that is changing in this question that we're recording, is flight times. We're told the flight times are normally distributed, and we're told that the mean, the average flight time, is 320 minutes, and we're told that the standard deviation is 20 minutes. So that's basically saying that we don't have a standard normal. Most of the flights take 320 minutes, some take more, and some take less. A. Find the probability that a flight takes exactly 315 minutes. Well, 315 is here. And the answer is 0. We can't find the probability at a single point for a continuous distribution like the normal distribution. So that was easy. Just need to remember that. How about B? What does B ask us to do? Find the probability that a flight takes less than 300 minutes. So, okay, so less than 300. So the mean 320. Standard deviation is 20. I want less than 300 minutes. So we need to find this area in here, which is very nice because XO works to the left and we can just use the norm dot dist function. The norm dot dist function has some values it wants. So it wants the 300 in there. Oops, that's the 300. Then it wants the mean. The mean we said is 320. The standard deviation comes next, and that is 20. And then 1. So that's how we calculate that. We could have actually said we want to work out, I'll show you here, the probability that x is less than 300. And that's going to be the probability that x is less than 300. And what we're going to do is subtract the mean from both sides. And the mean is going to be 320 here. And we're going to divide by the standard deviation on both sides. And the standard deviation we said is 20. And that's going to be x minus b over sigma is z, standard normal, and that's going to be 300 minus 320 is negative 20 over 20 is negative 1. And then we can just use norm dot s, because it's standard normal now, norm dot s dot dist of negative 1. I don't have to tell it the norm, the mean and standard deviation, because we know it's a standard normal. So I'm just going to put a 1 or true, saying I want to find the area. And what effectively this is here is the same question, but it's on the z distribution. And it's the same as part B above, but the mean is 0 and the standard deviation is 1. And instead of being less than 300, it's going to be less than negative 1. And this and this should give exactly the same results. So we can actually just pop over to XL and have them actually calculate that for us. Let's just do that. So the first way of doing it is using just norm.dist, and we want to put in there, it was less than 300, so we put the 300. The mean we said was 320, standard deviation is 20, and as always 1 or true, and that gives us a value of 15.86, and we could change that into a percentage by pressing the percentage key, can add a couple of decimal places. So that's one way of doing it using norm.dist. If you wanted to standardize it first, which you're very welcome to do, if that's what you'd like to do, what you're going to use then is going to be norm.s.dist, and the value we're going to put in there is going to be -1, that value that we calculated, and 1 cumulative, and that's giving us the same result. So you're not going to change the result by doing it one way or the other. It's just which way is available to you and which way you're asked to do it. So 15.87 is the result. So both of these give 15.87% as the answer. So put 15.87%, and that's actually going to be that area. So the probability that the flight times, sorry, it's that area as well. They're both the same. And yeah, and this one also going to give 15.87 down here. That's giving that area there. Happens to be giving the same as the area above. So the probability that a flight takes less than 300 minutes is 15.87%. Let's look at C. Find the probability that a flight takes more than 335 minutes. So C, we want the flight to take more than, let's see, that's our X, the mean is 320, the standard deviation is 20, and we're looking at the flight taking more than 335 minutes. Okay, so 335 is here. When you do the diagram, it's pretty cool because you can actually see that this area has got to be less than 50%, because half the area is 50%, half the area to the right is 50, and half the area to the left is 50, even though it might not be so clear from some of my diagrams. Now, if I calculate norm, I'm not going to standardize, just norm.dist. Remember, standardizing is just going through the process I went with the one above. This is the standardization process in here. I'm not going to go through the standardization process. I'm just going to do it from here. So if I do norm.dist of 335, so that's the 335 from in there, and then I'm going to put the mean, which is 320, the standard deviation, which is 20, and true. What do I get? So I can go to Excel and do that. I'm expecting to get a value which is less than 50%. This area in here, I would imagine is going to be less than 50%. It should be less than 50%. So when I go to Excel, if I put this in, I think I'm going to get an area greater than 50%. So we can try that to see what we actually get in Excel. Let's see what we get in Excel. So it's got, let's go over to Excel. So we can do equals norm.dist, .335, the mean is 320, standard deviation is 20, and 1 for true, and let's see what we get. So the answer to this question we know is going to be less than 50%, but here we're going to get an answer greater than 50%. We're actually getting 77% coming through here. Why are we getting 77%? There's no mistake in that. It really is 77.34%. So let's go back to here. So the actual answer is 77.34%. But Excel works to the left. So in fact, the answer this was giving us was the answer to the left. So it's this area in here. It's all this area over here. So all this area. That is 77.34%. The area that we want, change the color of it now. The area that we want, let's do that in green now. This is the area that we want to the right. So we have to use 1 minus what we've got above, 1 minus norm.dist 335, 320, 20, and 1. So in the questions above, XL works to the left, and we were fine, but this one, XL works to the left, but we actually required the area to the right. So there you go. So this is what we have to do. So let's just pop over to Excel. So it's in fact going to be 1 minus what we did earlier, and that gives us 22.66%. So the answer that we want is 22. How many decimal places shall we do it to? When you look at a question, this is two decimal places. If a question asks for 2 decimal places, that's fine. If it asks for 3 or 4, if you ask for 3 or 4, you can actually just change it about by pressing this key up here. That's for 3 to 4. You can change it to 1 decimal place. Takes out the guesswork. So let's put 22.66% if it's to 2 decimal places. So 22.66%. There you go. That's how you do that. And then what's the final part? Find the probability that a flight takes between 320 and 350 minutes. So C, 320 to D, 320 to 350. So 320 happens to be right there, and to 350 is here. I don't like that. Let's just get rid of that. So we need to find this area in here. So again, when we're between 2 points, as previous examples that we've done, we can use norm.dist. We're not going to bother standardizing it, we're just going to leave it in X. We're going to take it over to Z. So norm.dist, I can put the 350 in here, the mean of 320, the standard deviation of 20, and the 1. This will in fact give you the area from 350, where the mean is 320 and the standard deviation is 20, will give you all this area going all the way back, XL works to the left. Now that area is too much, so we actually want to stop this at 320. We don't want anything beyond that point, so we want to get rid of all of this. So what we need to do is, from this black area here, we need to subtract the red area, which is going to be norm.dist 320. So that point is 320, then we put in the mean, 320. Then we put in the standard deviation, which is 20 and 1, or true. And that will give us the area that we want. So we can actually just do that, pop over to Excel and just do that in Excel. So we can use norm equals norm.dist of 350. So the mean is 320. Standard deviation is 20 and 1. And that's the first bit. Then from that we need to subtract norm.dist of 320. Any ideas what this is going to come to, this second value? 320, 20. Is that going to come to 50%? Yeah. And let's take the difference. You could have done this in one go, it's up to you. So the answer is 43.3%. We can press the percentage, we can take it to 2 decimal places, so 43.32% is the answer, so 43.32%. So the answer for this is 43.32%. So the area in here is 43.32%. The reason I said the second part, this part in here of the calculation is going to be 0.5, is exactly half the distribution. Yeah, because remember the distribution is the distribution is doing a different color. The distribution, normal distribution, the mean is 320, and the second part wanted you to find the area from 320 going back, which is exactly 50% of it. I redrew it because this is slightly out of scale. And just one more note. Once we actually are in Excel, even if we forget what we're supposed to put in, Excel tells us, if you haven't noticed yet. So when I'm using norm.dis, for example, Excel tells me it wants X, and suppose X is 320. And then once I press the comma, you're going to see that the highlight's going to move away from the X and go onto the mean. So I'll tell you, oh, the mean is 320. And once I press the comma, it's going to tell me the next thing it wants, the standard deviation. And once I put the 20 and press the comma, it asks me for the next thing. So Excel leads us through quite nicely.